The intent of this video is to introduce you to some theorems about arcs and angles, and then show you how to use those theorems in writing some proofs about circles. Alright, all of the theorems that we're going to take a look at today should tie back to what you learned yesterday about inscribed, incentral angles, and some other facts that you should be aware of with respect to the circle. So at this point, if you have not yet watched the video on central and inscribed angles, you want to make a point to do that before venturing into this one regarding their theorems. Alright, the first theorem says anytime we have a circle and we have congruent central angles, their intercepted arcs have to be congruent as well. So in other words, if we take a look at what this is talking about in the picture, if we have two central angles there and there that are congruent, we know that they're central angles because their vertex is at the center of the circle. Then because the degree measure of their intercepted arcs is equal to the degree measure of the central angle, we know that their arcs have to be congruent as well. So if those two angles are congruent, their intercepted arcs have to be congruent as well. And the second theorem is just what we just said, but in reverse. Anytime those red arcs are congruent, we know that the blue central angles must be congruent as well. And again, that ties back to exactly what you learned in the last video. Alright, the next couple theorems talk about chords. Remember that a chord is a line segment whose endpoints are on the circle. So anybody whose endpoints are on the circle is a chord. Anytime this says you have two arcs that are congruent, that makes their corresponding chords congruent. So anytime you have arcs such as AB and CD which are congruent, what this is saying is that the chord that goes along with that arc has to be congruent to the chord that goes along with the second arc. And the converse of this is true as well. Anytime those blue chords are congruent, it must follow that the green arcs are congruent as well. Alright, this third theorem ties back, or pair of theorems ties back to what we learned yesterday too. Anytime you have congruent central angles, so again looking at the picture, that would mean that these two green angles are congruent, their chords have to be congruent as well. So the chord that would go along with that, the first angle, is this blue one. The chord that would go along with the second angle would be DC. So what this is saying is that if these two green angles are congruent, then it must follow that their blue chords are congruent as well. And the converse of this is true also. Anytime those blue chords are congruent, their central angles have to be congruent also. Alright, this one deals with inscribed angles. It says anytime you have a pair of inscribed angles that are congruent, their arcs must be congruent as well. So let's take a look at the picture and see if we can find a pair of inscribed angles. Remember that inscribed angles have a vertex that's on the circle. So one inscribed angle might be angle A, and a second inscribed angle might be angle C. So this theorem is saying that if these two angles are equal to each other, then their intercepted arcs have to be congruent to each other as well. Well, the intercepted arc for angle A is going to be arc CB. And if we look at the intercepted arc for angle C, that's going to be the arc from A to D. So again, what this is saying is that if angle A is congruent to angle C, then angle A's intercepted arc, arc BC, must be congruent to angle C's intercepted arc, which we said was AD. And the reverse of this is true as well. If we know that the green arcs are congruent, it must follow that the red inscribed angles are congruent also. Alright, the next one has to do with something that you should already know about. It just says anytime you have a circle, all of its radii are congruent. You can't have a circle where one radius is 12 and the other radius is 5. So all radii of the same circle must be congruent. So in other words, because OA, OB, OC, and OD are all radii of the circle, they all must be congruent to each other. And then the last one is my personal favorite. It says inscribed angles that intercept the same arc have to be congruent to each other. So again, I'm going to start with one arc down here. And if I start with arc from D to B, I'm going to say, are there a pair of inscribed angles that intercept that arc? Well, looking backwards, an inscribed angle for that arc would be angle A. A second inscribed angle for the same arc would be angle C. That tells me that angle A and angle C must be congruent because they're inscribed angles that intercept the same arc. All right, now down at the bottom of that page it says, in this picture, can you find a second pair of inscribed angles that both intercept the same arc? So I'm going to give you a minute to think about that. And now if you're challenged by this, I'm going to say look at arc AC and look for a pair of inscribed angles that'll intercept that arc. And we'll talk more about this when you come back to class the next time. All right, we're going to jump right into using some of these theorems to go ahead and write some proofs about circles. So in number 1 it says given that arc AB is the same as arc CD, they want us to prove a pair of angles are congruent. Just like we did with all of our other proof writing this year, the first thing I'm going to do is I'm going to go mark those givens in my diagram. So this arc from A to B is the same as this arc from C to D. I'm also going to take a look at what it is that I'm trying to prove. Where is it that I want to get to or be at when all is said and done? So I want to have angle ABC, this angle, congruent to angle DCB. And as soon as I see that pair of angles, I'm either thinking similar triangles or I'm thinking about trying to get a pair of triangles that contain those angles congruent so that I can use CPCTC. Well, if I look for a pair of angles or triangles that contain those angles, that blue triangle would be one. The green triangle would be a second one. If I could get those two triangles congruent, then I could use CPCTC to prove that my angles are congruent. Well, in looking at those two triangles, one thing I notice right off the bat is that they share side BC. It's the same in both. So a little reflexive property there will give me one pair of congruent sides. Another thing that I happen to notice about these two triangles with respect to these arcs, angle C, and I should call this angle 1, is an inscribed angle for arc AB, and an inscribed angle for arc CD is this guy over here, angle 2. And then the third and final thing that I notice about this, if I look at that yellow arc, BC, and I go backwards and look for a pair of inscribed angles for that yellow arc, I've got an angle up here at A and an angle up there at D that are both inscribed angles that intercept that arc. So that gives me a second pair of angles. So in the green triangle, I've got angle D, angle 2, pair of shared sides BC. In the blue triangle, I've got angle A, angle 1, pair of shared sides BC. That gives me a pair of congruent triangles. CPCTC then will make the angles congruent. So that's where I'm going to go with this proof. I'm going to start right off, and rather than start with the givens, I'm going to start somewhere else. But again, keeping in mind that my mission is to take what I've marked in this diagram and write about each of those congruent parts somewhere in my proof. So I marked angle A congruent to angle D. That was because they're a pair of inscribed angles that both intercept arc BC. I can go ahead and write angle A is congruent to angle D. And as for a reason why, inscribed, and I have to be very careful and tell exactly what kind of angles they are. Inscribed angles that intercept the same arc are congruent. If I go back to my picture, somewhere in my proof, I want to write about angle 1 being congruent to angle 2. I knew these guys were congruent because of the congruent arcs. So I'm going to go back and I'm going to start by writing about arc AB being congruent to arc CD. And then because those two arcs were congruent, that's what it was that told me that angle 1 had to be congruent to angle 2. And as for my reason, I'm going to start out by talking about those congruent arcs because that's what I started with, the congruent arcs. And I'm going to say have inscribed angles. And again, I'm going to be very descriptive and tell exactly what kind of angles they are that are congruent. So up until now, I have one pair of angles, two pairs of congruent angles. The last thing that I need to write about before I can have congruent triangles is side BC being congruent to itself. I like this one because it's pretty straightforward and simple. Those two are congruent to each other by the reflexive property. This is kind of cool because it's been a long time since we've written any proofs dealing with congruent triangles. So there's my pair of congruent sides. So if I pull all three of those together, what I end up with is a pair of congruent triangles. I'm going to be very careful when I name my congruent triangles and make sure that I get their corresponding parts in the right angle, or in the right order. So in the blue triangle, I'm going to call that triangle ACB. In the green triangle, the angle that corresponded to angle A was angle D, so I'm going to name him first. The angle that corresponded to C in the blue triangle is angle B in the green triangle. I'm going to name him second, and then I'll name angle C lastly. And I'm going to refer back to my picture just to make sure that I have the right triangle congruency. It was angle, angle, side. And now that those two triangles are congruent, I know that all of their corresponding parts are congruent, all their corresponding sides and all their corresponding angles. The ones that I want in this particular instance are ABC and DCB. So lastly, I'm going to wrap this up by saying that angle ABC is congruent to angle DCB. And I can talk about triangles being congruent and their corresponding parts being congruent. The abbreviation that we use for that, though, remember, is CPC-TC, or corresponding parts of congruent triangles are congruent. All right, congratulations, you just wrote your very first circle proof. Without any further ado, I'm going to head into the next one. Like the first one, I'm going to mark my pairs of, mark everything I've been given in the diagram first of all. So arc AC is congruent to arc AD. Mark it. BE is perpendicular to AC, mark it. BF is perpendicular to AD, mark it. B is the midpoint of segment CD, mark it. We're trying to prove, or we want to get to, or show that segment EB is congruent to segment FB. So I'm thinking that if I could prove a pair of triangles that contain those segments were congruent to each other, again, we can use a little CPC-TC. Well, those two little green triangles both contain the segments that I want to show congruent to each other, and it just so happens that at this point I already have one pair of congruent sides and one pair of congruent angles. I'm going to look to those congruent arcs because I haven't used them for anything else, for some other pairs of congruent either sides or angles. So in looking at this arc, I can work backwards and look to its inscribed angle, angle C. And likewise, if I look at this blue arc and work backwards, it leads me back to angle D. So because those blue arcs are congruent, I know that their inscribed angles are congruent as well, and that'll give me what I need to finish this problem up. All right, so somewhere in my proof I want to talk about angle C being congruent to angle D. I knew those guys were congruent because of the congruent arcs. So I'm going to start out by writing about the congruent arcs. And the congruent arcs is what gave me angle C congruent to angle D. I'm going to say congruent arcs have congruent inscribed angles. Okay, the next thing that I notice in my picture that I need to talk about in my proof is somewhere I need to talk about this right angle at point E being congruent to the right angle at point F. I can't call them angle E and angle F because there's more than one angle E and F in the picture, so I'm going to call them angle 1 and angle 2. I know they're right angles because of the perpendiculars that were talked about in the givens, so I'm going to go ahead and write about those segments being perpendicular. So segment BE is perpendicular to segment AC. Segment BF is perpendicular to segment AD, and I know that's a true statement, or those are true statements, because they're given to me to be true statements. And since those two segments are perpendicular, that makes angles 1 and angles 2 right angles. And I know this because perpendicular lines make right angles. And then once those two angles are right angles, I know that they have to be congruent to each other. And as for a reason why, all right angles are congruent. So up until now, I've got one pair of congruent angles, two pair of congruent angles. Somewhere I need to talk about segment BC being congruent to segment BD. I knew those two were congruent because of the fact that B is the midpoint of segment CD. So now I have to write about B being the midpoint of segment CD. And then because that guy is the midpoint, that's what told me that segments CB and BD were congruent to each other. So at this point, there's my first pair of angles, my second pair of angles, my pair of congruent sides. I can go ahead and pull all three of those together. And when I name my triangles, I have to make sure I name their corresponding parts together. So if I call the first triangle, triangle EBC, I need to call the second triangle, triangle FBD. And those triangles are congruent because of angle, angle, side. And then once those two triangles are congruent, I know that all their corresponding parts are congruent. The corresponding parts that I'm concerned about in this case are EB, segment EB, and segment FB. So if you have questions about anything in the video, please write them down so that you'll remember to ask the next time that you come to class. And also the next time that you come to class, be prepared to come in and practice writing some of these proofs that involve circles.